talk about the scenarios. How do we actually get the models where the machine drives inside? We have currently 3 ways. So in the end, what we always need is a Mevea and Unity environment model. And one thing we are doing is we actually use drone photogrammetry. So we have, a gravel pit or an industrial site or some kind of use case where the physical machine is running or should run in the future. We have a drone flying over, taking a couple of thousand of pictures and creating a 3D model based off it. And then we actually have the real customer environment where the physical machine should operate later, one-to-one as a digital representation, which is of course very helpful because you're actually testing exactly what the real machine should do in the future.
And Mevea environment can integrate best from both applications, detailed control system from Simulink to real-world physics. And in this use case, for example, the ground resistance in digging operation is a challenge to any simulation software. But with co-simulation with Mevea and Simulink, we can have virtual testing with full machine dynamics. And I think that's one of the key benefits here as well. So what we did in this is the system architecture that we used to demonstrate. We also had this kind of implementation in our booth at Bauma 2025. So we used Mevea modeling tools to model EMAs in this ready-made mini excavator. Then Mevea solver, which had the equipment, the virtual work process, virtual sensors, virtual environment, and I/O interface. And then we developed the EMA model that we also already had. We exported the functional mockup unit from Simulink. Then that we imported to Mevea solver. So we have the Simulink control system and EMA model to the Mevea simulation. This would also be possible to have the interface for hardware in the loop, but that was not the key focus point here. So we just used common joysticks for testing. And then there was a bonus that you can have also the visualization of the system.
All right, so in the presentation that I prepared for you, we're going to take a look at an example where we are doing a virtual test of an excavator, combining the simulation capabilities in Simscape, which is part of the products offered by MathWorks. You may know MATLAB and Simulink, combined with Mevea. And before I dive into the slides themselves, I'm going to show you an animation of the use case that we put together. So you can see an animation on the screen. On the left side, you can see the animation of the Mevea environment. And on the right-hand side, you can see the animation from the Simscape environment. On the Simscape side, we're modeling the mechanical system, the hydraulic system, controls, and electrical system. And we're relying on Mevea for the soil loads, both on the bucket and as the tracks interact with the ground. For various use cases, you might need to combine all of these different simulation capabilities. So we put this example together to show how you can combine them together and some of the ways you can set up the co-simulation to include just the effects that you need.
And in Mevea architecture, we offer several possibilities to integrate to different phases of R&D work. On the modeling level, there are interfaces, for example, ANSYS, for definition of structural flexible components, or exporting the URDF file for robotics tools. Different co-simulation solutions we have been already discussed today, and those enable the use of the existing models and tool chains on familiar way, because using a tool coupling FMU enables the use of Mevea models as an extension for existing systems. But I'll show an example of that a bit later. And then the I/O interface, as mentioned, and the APIs enable the communication with third-party software for visualization or control systems using the common protocols. And then the visualization environments offer the possibility to implement the environment perception sensors, additional objects that need to be used in the autonomous functionality development, but I'll show an example related to that also a bit later. And then the command line interface, as mentioned, integrated Python scripts enable to set up and integration to the automated testing system.